Good evening, dear students. Yes, so yesterday there was some network issue. Okay, so we were discussing about the preparation of aldehydes. Okay, so that only we are going to continue. Yes. Okay, so let us start. So these things already we have discussed in our previous classes. Okay, so let us go directly with the preparation of aldehydes. So this we have discussed. That is how to prepare only aldehydes, okay, from acyl chlorides, then from nitriles and esters, okay. Then we have also discussed from hydrocarbons how we get the aldehydes, okay. So we are going to use different oxidizing agents. So here we are using chromyl chloride test, okay. And this chromyl chloride test, what it does, it oxidizes your methyl group, okay, to a chromium complex, which on further hydrolysis will give you a corresponding benzaldehyde. Okay, and this name reaction, it is called as what? It is called as a Itard reaction. Very, very important name reaction. That is the Itard reaction. Okay. Yes. So next is, which we are going to discuss, is use of chromic acid oxide. Okay. So by using chromyl chloride, we are converting the corresponding toluene, okay, to a aldehyde. So here we are using chromic oxide. What we are using here? Chromic oxide. So what is chromic oxide? CrO3. Okay, the formula for chromic oxide is CrO3. So we are using a benzene substituted. Okay, so here it is a toluene. So methyl group is a substituted. Okay, so to a benzene ring. So this is toluene. So what we are doing, we converting this toluene, or you can take any substituted toluene. Okay, and we are converting into what? We are converting it into a benzaldehyde. Okay. So first, the first scene is what? First, we are treating it with chromic acid. Okay, chromic acid. Okay, in the presence of acetic anhydride. Okay, what is acetic anhydride? So this is the acetic anhydride, the form. So the structure of acetic anhydride. So in the presence of acetic anhydride, okay, your chromic acid, it reacts and it gives you a benzidylene diacetate. Okay, benzidylene diacetate. So what is happening here? The acetate ions are replaced. Okay, your two of the hydrogens from the methyl group are being replaced by your acetyl group. Okay, then this benzidylene diacetate, what we are doing further, we are heating it. Okay, with respect to hydrolysis, we are heating this benzidylene diacetate and we are going to get benzaldehyde. Okay, benzaldehyde. So another reaction where we can convert our toluene or any substituted toluene to benzaldehyde via benzidylene diacetate. So what is happening here? The hydrogens, okay, the hydrogens. So how many hydrogens are there? Three hydrogens. So out of three, so two of the hydrogens are replaced by the acetyl group. Okay. Yes. So this is how we are using the chromic oxide in acetic anhydride. So how we are going to convert? We are going to use chromic oxide in acetic anhydride. Okay. So what will be the intermediate? It is going to give benzidylene diacetate. Okay. And this benzidylene acetate, it is going to go acid hydrolysis. Okay. On heating, we are going to get benzaldehyde. So here the temperature condition, it is 273 to 283 Kelvin. Okay, so this is the temperature which we have to maintain. Okay, fine. So this is another method of preparation of your aldehyde. Okay, let us go for the next one. So next is by side chain chlorination, okay, followed by hydrolysis. So another method for preparation of benzaldehyde. So what we are taking a toluene compound, okay, and this is one of the commercial method. What do you mean by commercial method, students? Commercial means, yes, we are preparing the benzaldehyde at a large scale, okay, at a large scale, at commercial scale, okay. So this is a commercial method where we are preparing the benzaldehyde. So what we are doing? We are doing side chain chlorination. Okay, we are only chlorinating the side chain. What is our side chain in the toluene? That is our CH3 group. So we are doing chlorination. So how we are chlorinating? What is the reagent? chlorine in the presence of H nu. Okay, chlorine in the presence of H nu. So what we are going to get? What will happen here? So two hydrogens. Okay, two of the hydrogens are replaced by your Cl2. There are two atoms of chlorine. Okay, so two atoms of chlorine replaces your hydrogen atom. What you get? You get a benzyl chloride. Okay, what you get? Benzyl chloride. Okay, so this is first step of chlorination. Further, you're going to do hydrolysis. What do you mean by hydrolysis? Addition of water. Okay, we are adding water. So hydrolysis takes place, okay, at 373 Kelvin. Okay, so you're boiling. Okay, 373, 273 plus 100 is 270. Right. So you're boiling it. So what is happening here? You're heating it with water, and what you get? You get a benzaldehyde, and HCl will be your byproduct. Okay, so this is another method where you can prepare benzaldehyde, and this is a commercial method at very large scale. Okay, you can at a very convenient or at a large scale, you can prepare your benzaldehyde. Okay, so by side chain chlorination. Is it clear? Okay, so we have seen the two reactions. So first one was by using how to use a chromic oxide on in acetic anhydride. Okay, so we get benzaldehyde, acetylene, diacetate followed by hydrolysis to give you benzaldehyde. Okay, and then we have seen by side chain chlorination and followed by your hydrolysis. So next reaction is by Gatterman-Koch reaction. So very, very important. Again, a very important main reaction. This is for 2 marks. Okay, the question asked, so it is asked question for 2 marks. So by Gatterman-Koch reaction. So what we are doing in Gatterman-Koch reactions? So benzene, okay, you can take benzene or any of its derivative. Okay, and we are going to treat it with carbon monoxide in the presence of hydrochloric okay, hydrochloric your HCl, that is hydrochloric acid. Okay, in the presence of any so you're taking anhydrous aluminum, okay, aluminum chloride or your copper chloride. Okay, and it gives you what? It gives you a benzaldehyde or substituted benzaldehyde. Okay, so this is a Gatterman-Koch reaction. So how? So we are going to prepare benzaldehyde. Okay, so we are going to take benzene, or you can take any of its derivative. We are going. What are the reagents which are used in Gatterman-Koch reaction? Carbon monoxide. Okay, in the presence of HCl. Okay, hydrochloric acid. Okay, and anhydrous AlCl3. That is aluminum chloride, trichloride, or you can use copper chloride. Okay, cuprous chloride. What it gives you? It gives you benzaldehyde. If you take benzene, you'll get benzaldehyde. If you take any substituted benzaldehyde, then you are going to substituted benzene, you are going to get a substituted benzaldehyde. Is it clear? Okay, so this is another name reaction, that is Gatterman-Koch reaction. Okay, next is the preparation of ketones. Okay, preparations of ketones. So these what the name reactions we have seen. Here we are preparing all the aldehydes. Okay, only aldehydes can be prepared by this method. Now the reactions which we are seeing. So from these reactions, only what we can do, we can prepare the ketones. Okay, what we can prepare? We can prepare ketones. So first one is from acyl chlorides. Okay, from acyl chlorides. So what we are doing? So here the ketones. Okay, you can get ketones by reacting it with acyl chloride. Okay, and you are going to use dialkyl cadmium. Okay, what is dialkyl cadmium? So 2R2CD. Okay, this is dialkyl cadmium. Okay, and this is obtained. How you are going to obtain this dialkyl cadmium? When you react your this cadmium chloride. Okay, when you react cadmium chloride, okay, by the reaction of cadmium chloride with Grignard reagent RMGX. Okay, so when you react your cadmium chloride with Grignard reagent, what is Grignard reagent? So Grignard reagent is RMGX. Okay, RMGX, that is your Grignard reagent, which is also called as organometallic reagent. Okay, so cadmium chloride, we are reacting it with what? We are reacting it with Grignard reagent. Okay, and what we are going to get here? Yes, what we are going to get? We are going to get R2. Okay, so R2 cad okay CD, that is dialkyl cadmium. plus 2 mg HCl. Okay, 2 mg HCl. So this is the reaction which we are getting. Okay, now what we are going to do? First, we have obtained, so RMgX is the Grignard reagent that we are reacting with the cadmium dichloride. I am going to get dialkyl cadmium, okay, plus 2 mg HCl. Now this dialkyl cadmium, what I'm going to do? I'm going to treat it with acyl chloride. Now what is acyl chloride? RC double bond O Cl. Okay, acid chlorides, right? Acyl chloride. So here we are taking here, what we are taking? RC double bond O Cl. So 2 moles of acyl chloride. We are reacting it with dialkyl cadmium. Okay, we are reacting it with dialkyl cadmium. What are we going to get? Yes, this will react, okay, with the cadmium, and we are going to get RC double bond O R dash, okay, plus cadmium dichloride, okay, plus cadmium dichloride. Did you get it? Yes, did you get it? Understood? Okay. So from acyl chloride, so what we are doing, we are treating the treatment of acyl chlorides with dialkyl cadmium. Okay, prepared by the reaction of cadmium chloride with Grignard reagent, it gives you ketone. Okay, so one more time I'll explain. So we require dialkyl cadmium. Okay, how this dialkyl cadmium is prepared? We are going to take Grignard reagent. Okay, that is RMgX. We are going to react it with cadmium dichloride. Okay, so cadmium dichloride, then so 2 molecules. So I am going to get cadmium R2, okay, that is dialkyl cadmium plus 2 MgX and Cl. So this is the, now this dialkyl cadmium, I am going to react it with what? Acyl chloride plus RCdR2, if I write like this for your better understanding. So what it will become? Okay, it will become like this. Okay, so what it will become? So I'm going to get 2R, okay, 2R C double bond O R dash plus CdCl2. Is it clear? Okay, fine. So let us continue. So this is the first preparation of your this. So now if I give you an example, so let me give you an example, okay? So let us see example. So if I take, so it depends on what R dash and R2 you take. Okay, first example, if I take a acetyl chloride. Okay, what is acetyl chloride, student? CHC, C double bond O, Cl. Okay, so 2 molecules of acetyl chloride reacts with, so let me take R as dimethyl. Okay, so dimethyl cadmium. What I'm going to get? What will be the product? Yes, what will be the product here? What will be the product? So the product will be CH3, C double bond O, CH3, okay, twice, plus CdCl2. Okay, so this is the product. So what I got? I got the acetone. So the name of the ketone is acetone. Okay, the name of the ketone is acetone. Okay, so let us go for the one more reaction. So let me take what is this name? Can anybody tell me what is the name of this compound? Yes, you can use the chat box to answer. You can use the chat box to answer. So again, I'll take dialkyl group as dimethyl. Okay, and what is the name of the compound? What I've taken? Yes, students. What is the name? It is benzoyl chloride, right? It is benzoyl chloride. So this benzoyl chloride, when you react it with dimethyl cadmium, what I'm going to get? What I'm going to get? What is the product? Tell me the product name. So the, okay, so the answer is this. Okay, so I'm going to get acetophenone. Okay, I'm going to get acetophenone plus cadmium dichloride. Okay, So both the types of ketones can be prepared. So both, so this is a aliphatic, okay, aliphatic ketone, and this is a aromatic ketone. So both type of ketones can be prepared. Okay, I can prepare aliphatic as well as aromatic ketones can be prepared. Is it clear? Is it clear? Okay. So let us go for the next one. So next is from nitriles. Okay, next is from nitriles. So what we are doing here? So treating nitriles are nothing but your cyanides. Okay, nitriles are nothing but your cyanide. So again, we are going to treat the cyanide. So RC triple bond N is your cyanide. I'm going to react it with Grignard reagent. Okay, RMgX. So this is positive, this is negative. Okay, and the solvent we are using is a dry solvent. Okay, that is a dry ether. Okay, the solvent is dry ether. So what we are using? We are treating our nitrile with what? We are treating our cyanide with Grignard reagent. Okay, what I'm going to get? So this will attack the, okay, cyanide, okay, triple bond cyanide, that's cyanide carbon. Then what I'm going to get? So RC R dash. Okay, let me take this as R dash. Then double bond N MgX. Okay, this further undergoes hydrolysis. This further undergoes hydrolysis to give you what? RC double bond O R dash plus MgX OH. Okay, plus NH3 plus NH3. So these are the byproducts. Okay, these are the products. So this is the way we are going to cover. Now let me take one reaction. So they have taken propane nitride, CH3, CH2, and C triple bond N. So it is what? 1, 2, 3. Okay, propane nitrile. The number of carbon atoms are 3. So it is propane nitrile. Okay, propane nitrile. What I'll take? I'll take C6H5. Okay, so phenyl magnesium bromide, okay, react it with the presence of dry ether. What I'm going to get? So this is going to attack this. So I'm going to get CH3, CH2, C, C6H5, okay, then N, then MgBr. This further undergoes hydrolysis to give you what? CH3, CH2, C, C6H5. Okay, double bond plus NH3 plus MgBr and OH. Okay, is it clear? So what is the name of this compound? Okay, so one is a ethyl group and another is a phenyl group. So which comes first? Ethyl comes first. So it is a ethyl phenyl ketone. Okay, ethyl phenyl ketone. Is it clear? Is it clear? Okay, so it is a ethyl phenyl ketone. So in from this also, from nitriles also, you can prepare both aliphatic as well as aromatic ketones. Okay, can be prepared by this method. Is it clear? Okay, let us continue. So next is from benzene or substituted benzene. Okay, next we can use form the we can get the ketones from benzene or substituted benzene. Okay, so that is also called as the Friedel-Crafts. Okay, Friedel-Crafts acylation. So we are doing acylation. Again, introduction of a acetyl group. So what we are doing, we are treating. So very, very important. Mark this as important for 2 marks. Mark this as important for 2 marks. Okay. So benzene we are taking. Okay, we are taking benzene. What we are reacting? We are reacting it with what? We are reacting it with the acid chloride. Okay, we are reacting it with acid chloride in the presence of anhydrous AlCl3 as a catalyst. So which catalyst you are using? Anhydrous AlCl3. And the solvent uses carbon disulfide. Okay, what I am going to get? So which is the, so this is your incoming electrophile. So the incoming electrophile, that is your C double bond to R. So, okay, so this will attack. Okay, this will get what you get the corresponding ketone. Okay, so like this, you are going to get the ketone. So this is also called as a Friedel-Crafts acylation because we are introducing the acyl group. Okay, we are introducing the acyl group on the benzene, so it is called as a Friedel-Crafts acylation. Is it clear? Okay, so let me give you one more example. Okay, so this is our benzene. Okay, so this is our benzene. So mark this as important for 2 marks. So benzene, let me take benzene plus. So what shall I take R? Let me take R as CH3. Okay, so this is my acetyl chloride. So this is my benzene. Okay, and this is my acetyl chloride. This is my acetyl chloride. So what it is reacted in the presence of anhydrous AlC3. Okay, so what I'm going to get, I'm going to introduce my acetyl group, okay, on the benzene. So this is acetophenone. Okay, and this is acetophenone plus HCl. Okay, plus HCl. So from benzene or substituted benzene, you can get the product. Is it clear? You can get the ketone. Okay, so you can take any R here. Okay, you can take ethyl, propyl, butyl. Okay, etc. Next is, okay, so let me take one more example. So benzene. Okay, so now I have taken acetyl chloride. So let me take a benzyl chloride. Okay, so this is my benzoyl chloride. Benzoyl chloride. So if I take benzoyl chloride, what will be the reaction, students? In the presence of anhydrous AlCl3? Yes, what will be the reaction? So I'm going to get C double bond O. C6H5 is nothing but your benzene. So I'm going to get a diphenyl ketone, or it is a benzophenone. Okay, I'm going to get a benzophenone. I'm going to get a diphenyl ketone, okay, or a benzophenone. Fine, plus HCl, plus HCl. Okay, so from benzene or substituted benzene, we can get such ketones. Okay, so this is called as a Friedel-Crafts acylation because we are introducing a acyl group. So this is one of the acyl group. Okay, yes. Next is from dry distillation of acid. So by using dry distillation, so you can convert the acids into ketone. Okay, by using calcium hydroxide. Okay, by using calcium hydroxide, so it will, what it will do, it will abstract the moisture. Okay, and you are going to get ketone. Okay, let us go for the next one. Yes. Okay, so okay, can you do it yourself? Yes, can you tell these answers? So we have benzene. Okay, here we have benzene. React it with your C2H5. Okay, that is your ethyl group. So this is a ethyl chloride. Okay, ethyl chloride in the presence of anhydrous AlCl3 and carbon disulfide. So what I'm going to get here? What I'm going to get? So benzene is there. Okay, I'm going to get CO, C2H5 plus HCl. Okay, so this is the compound. So ethyl phenyl ketone. So ethyl phenyl ketone. Okay, and so this is the name of the compound. Next, we are using what? C6H5 CH2 twice cadmium plus acetyl chloride. How you are going to do this? How we are going to do? So the product is CH3Cl2. One is CH3Cl2. Another will be what? C6H5 CH2 twice. Okay, C double bond O CH3. So what is the name? What is the name here? So it is benzyl. Okay, benzyl methyl ketone. Okay, so benzyl methyl ketone. So this is the name. Okay, methyl ketone. Okay, and okay. Next, your we have a propene. Okay, so we have a triple bond. So we have a propene, propylene. We have, so in the presence of Hg plus and dilute H2SO4, what I'm going to get? Use the whatever name reactions we have studied till now and give the answers. Yes, what we are going to. So I'm going to get acetone. Okay, so I'm going to get acetone. So which is this reaction Hg plus 3 and dilute H2SO4? Yes, HgH2 and dilute H2SO4. Tell me. Okay, so we are converting that is alkenes into ketone. Okay, the common reactions where we can convert alkenes into aldehydes and ketone. Okay, next, okay, we have here a substituted toluene. Okay, in the presence of chromyl chloride followed by hydrolysis, what we are going to get? Your CH3 will be converted to aldehyde group. Okay, first it will be converted into chromium complex followed by the this. So the name is para nitro benzaldehyde. Okay, the name is para nitro. Okay, benzaldehyde. Okay, fine, fine. So these are the answers. Okay, I hope you have got it. So next we are going to discuss the physical properties. Okay, physical state. Okay, so methanol is a gas at room temperature. Ethanol is a volatile liquid. Okay, so these are the physical properties for aldehydes and ketones. So when you discuss about the physical states, okay, so how it appears to be. So methanol, it is a gas. Ethanol is a liquid, and other aldehydes and ketones are liquid or solid at room temperature. Okay, so ethanol. So methanol is a gas, ethanol is a liquid, volatile liquid, and other liquid and gas is what? Aldehydes and ketones are liquid or solid. Then when we discuss about the boiling point, okay, so the boiling points of aldehydes and ketones are higher than hydrocarbons. So when we see the hydrocarbons, okay, hydrocarbons, suppose CH4. Okay, so aldehydes, the aldehyde, that is C double bond R, C double bond H, and R, C double bond O, R dash. So the boiling point of aldehydes and ketones is higher, okay, than your hydrocarbons and ethers of comparable molecular size. So why? It is due to the weak molecular association in aldehydes and ketones. Okay, so it which is due to the dipole-dipole interaction, and their boiling points also are lower than the alcohols, uh, okay, which are of the similar molecular masses. Why? What is the reason? Because of the absence of intermolecular hydrogen bonding. Okay, so if there is an absence of intermolecular hydrogen bonding, so what will happen to the boiling point? Boiling point will be low. Okay, so the boiling point of aldehydes and ketones, they are low as compared to the other hydrocarbons, okay, of comparable size. Next is solubility. So when we discuss about solubility, how worse is the compound to get soluble in water? So the lower members, okay, the lower members of, so the lower members of aldehydes and ketones, okay, they such as your methanol, your ethanol, and propanol are they miscible in water. Okay, but they form hydrogen bond with water. So why they form? Why they are when they are soluble? That means when they are soluble, that means they have to be forming hydrogen bonding. So there should be presence of hydrogen bonding. Okay, so the solubility of aldehydes and ketone it decreases. Okay, as the alkyl chain increases. Okay, so all the aldehydes and ketones, they are fairly soluble in organic solvents like your benzene, ether, methanol, and chloroform. So the lower aldehydes and ketones, they are soluble in water because they can form hydrogen bonding. As you go to the higher aldehydes and ketones, they are not soluble in water, but they are soluble in the organic solvents. Okay. Yes. Next is the odor. Okay. Odor means smell, how it smells. The lower aldehydes, they have a sharp, pungent smell. What do you mean by pungent smell? It is a bad smell. Okay. It has a very bad smell. Okay, as the size of the molecule increases, the odor becomes less pungent. So the lower aldehydes, they have very bad smell. As the size increases, what happens? The bad smell, it goes on decreasing. Okay, and you get a more fragrant smell. So many naturally occurring aldehydes and ketones, they are used in blending of perfumes and flavoring agents. So the aldehydes, most of the aldehydes which are naturally available, they are used in making your perfumes, okay, and flavoring agents. So this is about your odor. Odor means how the smell will be, okay? Yes. Next, let us see the chemical reactions. So let us see the chemical reactions. Okay. So chemical reaction means how the attack takes place. Okay. How the reaction takes place. So aldehydes and ketones, they both undergo nucleophilic addition. Okay. How the nucleophilic addition takes place. So you can see the carbonyl carbon. Okay. This is what it is sp2 hybridized. The carbon is sp2 hybridized. Why? Because it is attached to a double bond carbon. So how the nucleophile attacks? The nucleophile attacks from the either side of the carbon. Okay, and what it will do? It will polarize the bond. As it attacks, nucleophile is highly electronegative. It will attack the carbon. Okay, as a result, there will be partial positive charge on carbon and partial positive charge on your oxygen, and the bond that is the C double bond O bond is polarized. Okay, then what it will do, it will undergo a very slow step. So this is a very slow step, and this attack will take place. Okay, and the carbon nucleophile and the oxygen atom, okay, anion, it will undergo a tetrahedral formation. So it undergoes a tetrahedral formation. So as the attack takes place, so nucleophile get attached, okay, carbon, so and O minus I. So now what will happen as O, you can see that your carbon ion. Okay, so what is happening? You can see, first we'll see again. So nucleophile is attacking the your planar carbon, which is sp2 hybridized, okay, of the carbonyl group. Okay, and so the hybridization you can see from sp2 it has changed to sp3. So here you can see the carbon hybridization is sp3 and it is having a tetrahedral form. And you can see there is a formation of a alkoxide ion. So this alkoxide ion which is present, what it does in a fast step, it accepts the proton, okay, and it forms a neutral addition product. Okay, so this overall process, what you can see, or the overall reaction you can see, it is the addition of nucleophile and your proton across your carbonyl carbon. Okay, so so what does aldehyde and ketones undergo? They undergo a nucleophilic addition reaction. What does it undergoes? It undergoes a nucleophilic addition reaction. So once more, I'll explain the mechanism. So nucleophile will attack the carbonyl carbon, okay, which is planar, which is carbon is sp2 hybridized, okay, and it attacks the carbon in such a way which is perpendicular to the direction, okay, of the plane. And what is happens as the nucleophile attacks the carbonic carbon, there is a carbon carbonyl that is C double bond O bond, it get polarized. As a result, carbon will get a partial positive charge, oxygen will get the partial negative charge, okay, and the reaction undergoes a slow step. Okay, so what it undergoes, it goes via a tetrahedral, so it forms a tetrahedral. So nucleophile attacks, Okay, and there is a formation alkoxide ion. This alkoxide ion, okay, to be stable, what it does, it accepts the proton. Okay, it accepts the proton, and it forms a addition product. Okay, so the overall reaction, what it involves, the addition of nucleophile and the proton to the carbonyl carbon. Is it clear? Clear? Yes. Okay. So this is about the mechanism. This is about the mechanism. Okay. So next we will see the reactivity, how the reactivity takes place. So aldehydes are generally more reactive than ketones in nucleophilic addition reaction. So when we are discussing the nucleophilic addition reaction, so these aldehydes, okay, the aldehydes are more reactive. Aldehydes are more reactive than your ketones in this nucleophilic addition reaction. Why the ketones are showing lower reactivity? We said that aldehydes have higher reactivity. Then why the ketones show lower reactivity? So there are two reasons. Mainly, first is ketones have two alkyl groups. That is why more steric hindrance is present in ketone. So when we see the structure of aldehyde and ketone, so this is aldehyde, this is ketone. Okay. So there is a presence of two alkyl group. Okay. So when you have two alkyl group, what will happen? There is a steric hindrance. So attacking will take place difficult. Okay. So because of this one reason, then second is plus I effect increases. Okay. And electron density on carbonyl carbon. So as there is a alkyl group, what will happen? The electron the plus I effect increases. Okay, plus I effect increases. So as a result, the partial positive charge on carbon goes on decreasing. Okay, so as a plus I effect is there, so partial positive charge on carbonyl carbon, it goes on decreasing. Okay, so this is a reason why aldehydes react faster, okay, or more reactive than the ketones. So remember these two important reasons. Okay, why ketones are less reactive towards the your aldehydes. Okay, when it undergoes a nucleophilic addition reaction. So positive charge. So this you can see, this is a ketone. So how it undergoes resonization, resonance structure. Okay. So carbonyl carbon, so it get polarized. Okay. This alkoxide ion, so it gets stabilized. So the plus charge. So this is a resonance structure. So you can see the positive charge get developed on ortho. Okay. Para. Okay, due to the decrease in electron density on this position. So the electron density is less at ortho and para position. Okay, so because of that, you can see, and at meta, okay, because of the effect of carbonyl group, as this is a electron withdrawing group. So, so the lesser reactivity towards nucleophilic addition than the aliphatic aldehyde. Okay, so you can see the it takes place at ortho and para position. Okay. Next. So in general, aliphatic aldehydes are more reactive than aromatic aldehydes, then aliphatic ketone and aromatic ketone. So reactivity towards reaction, nucleophilic reaction decreases. So which are more reactive? Aliphatic aldehydes, then aromatic aldehydes, then aliphatic ketone, and aromatic ketones are the least reactive. Okay. Yes. So let us see some of the important examples of nucleophilic addition and nucleophilic elimination reaction. So addition and elimination reaction. Okay, so first is addition of hydrogen cyanide. So how we are going to add a molecule of hydrogen cyanide across the carbonyl group. Okay, so very, very important. Mark this as important for 2 marks. Okay, mark this as important for 2 marks. So 2 mark question. Okay, a 2 mark question. So very, very important. Okay. Hmm. So very important 2 mark question. So aldehyde and ketones, they react with your hydrogen cyanide, and what it forms? It forms a cyanohydride. So how the reactant, so how the reaction takes place, students? How the reaction takes place? See here. So how the nucleophile is generated. Okay, cyanide. Okay, that is your cyanide, your hydrogen cyanide. Okay, it reacts with your base OH minus and it forms H2O plus cyanide ion is the nucleophile which is generated. Now we have a carbonyl carbon. Okay, we have a carbonyl carbon. Now there is a plus cyanide ion. Now this cyanide ion will attack the carbonyl carbon and the bond is polarized. So this is a slow reaction. And what happens? So there will be CO minus. Okay, then here is the CN. Okay, so this is the intermediate. So this is a tetrahedral intermediate which is formed. Okay, this is a tetrahedral intermediate which is formed. And what is happened at last? Fast proton is added to the alkoxide, and what we are going to get? COH and CN. So what is formed? Cyanohydrine. Okay, what is formed is cyanohydrine. Is it clear? Is it clear, students? Okay. Now let me take, so I can take any this R. Okay, let me take any R. So I have taken CH3. Okay, let me take it as CH3. So what will be the changes? Okay, let me take it as CH3. So what is that? It is acetone. So acetone reacting with cyanide. So it will go at tetrahedral. So it will be CH3. So this will be CH3, CH3. What will be the name? It is acetaldehyde, acetaldehyde cyanohydrine. Okay, acetaldehyde cyanohydrine. Understood? Okay. So addition of hydrogen cyanide. Addition of hydrogen cyanide. So very important. 2 marks question. Okay. Yes. Let us go for the next one. Next nucleophilic addition reaction. Next nucleophilic addition reaction. Okay. Okay. So next is addition of sodium hydrogen sulfate. Okay. What is sodium hydrogen sulfate? NeHSO3. Okay. NeHSO3 is sodium hydrogen sulfide, or it is called as the sodium bisulfite. Okay. It is called as sodium bisulfite. Okay. It is called as sodium bisulfite. Okay, it is called as sodium bisulfite. So what we have done, we have taken a carbonyl carbon, we are reacting with sodium bisulfite. So sodium bisulfite, which is the nucleophile. Okay, it is SO3H. Okay, it is HSO3H. Okay, HSO3 minus. Okay, Na plus and HSO3 minus. So this is a nucleophile. So what will happen? So let me write it here. Okay, let me change the color. So let me write it here. So we have a carbonyl carbon. Okay, we have a carbonyl carbon. So let me generate this first. So NaHSO3. Okay, it gives you Na plus HSO3 minus. So our nucleophile is this. So let me take a your then HSO3 minus. Okay. So what will happen? So SO3 minus will attack this, polarize the bond. What I'm going to get? So I'm going to get CO minus and SO3H. Further, this is a slow, this is a fast attack of this. Okay. So I'm going to get COH, SO3H. So what is this? What is the name? The name is, yes, what will be the name, students? It is bisulfite, bisulfite addition compound. Okay, bisulfite addition compound. So this is the compound which we have got. Okay, so let me see with the example. So let me take a aldehyde. So let one aldehyde, this be acetaldehyde. Okay, let it be acetaldehyde. So acetaldehyde reacting with sodium, your hydrogen sulfide. Okay, which is HSO3 minus the nucleophile generated. First step is a slow step. Okay, and Na plus. Okay, here one sodium will be there. No, so what will happen? Sodium will go and attack here. Okay, so this becomes SO3Na. Okay, and this becomes OH. Okay, yes. Okay, so this becomes SO3Na and NaSO3, and this become H. Okay, so again the it will take place. Okay, so now with respect to acetaldehyde, what will be the answer? So here will be acetaldehyde. This is H. This will be CH3. This will be H. Okay, like this. So what is the name? It is acetaldehyde sodium bisulfite. Okay, it is acetaldehyde sodium bisulfite. Okay, so this is the product. Next, one more example I'll take. So CH3, C double bond O, CH3 plus NaHSO3. So when NaHSO3 reacts with this, what I'm going to get? I'm going to get CH3, C, O, Na, O minus Na plus. This is CH3 and this is SO3H. This on further attack of this, what I'm going to get? CH3, COH, CH3 and SO3 Na. What is the name? It is acetone sodium bisulfite. Okay, acetone sodium bisulfite. So another nucleophilic addition reaction by using sodium hydrogen sulfide. Next, we are going to see addition of alcohols. Okay, addition of alcohol. So let us see how to add the alcohols. Okay. So as your alcohols, what we are doing? We are reacting the alcohols. Okay. So your acetaldehyde is taken. We are reacting with one molecule of alcohol. So I'm going to get hemiacetal. When you react with one more molecule of alcohol, I'm going to get a what? I'm going to get a acetal. Okay, so this is not hemi, this is acetal. Okay, so aldehydes first react with one molecule of monohydric alcohol, okay, to give you alkoxy alcohol. Intermediate, which is hemiacetal, which further reacts with one more molecule of alcohol to give you acetal. So this is the reaction. So let me give an example. So let me take RSCH3, C double bond O, H. So react it with which alcohol? Let me take ethyl alcohol. Okay, let me take ethyl alcohol. So what will be the product, student? So it will be CH3, C, H, O, C2H5 and OH. So this is one hemiacetal. So again react it with one more molecule of alcohol. What I'm going to get? So CH3, C, H, O, C2H5 and OC2H5 plus water. So I have got a acetaldehyde, acetaldehyde, ethyl acetal. Okay, acetaldehyde. So this is acetaldehyde compound. This is ethyl. Okay, and acetal. Okay, so this is the compound. Is it clear? So this is addition of alcohols. This is the addition of alcohol. So we are seeing what? We are seeing the nucleophilic addition reactions. Okay, we are seeing the nucleophilic addition reaction. So in nucleophilic addition reactions, so what we are doing? We are doing the addition of alcohols. So across the aldehydes, okay, one molecule first of alcohol is added. So we get a hemiacetal. Further, what happens? One more molecule of alcohol is added. What we get? We got a acetal. Okay, we got a acetal. Is it clear? Yes. Yes. So let us go to the next concept. So ketones react with ethylene glycol under, okay, this we have finished. So ketones react with ethylene glycol under similar condition, okay, to form cyclic compound products, which is known as ethynyl glycol ketone. So this is a molecule of ethynyl glycol. So this is what ethylene glycol. So we are reacting it with what? We are reacting it with a ketone. So ketone is there and ethylene glycol. So what is happening here? It forms a cyclic compound. It forms a cyclic compound with elimination of water. Okay, with elimination of water. So what it forms? R, so O. This CH2 joins and O. So this is a ethylene glycol ketone followed by water. So again, so very important reaction. Okay, mark this as important. Okay, so here you can see there is a formation of what? Ethylene glycol ketone. So a cyclic product is formed. Okay, a cyclic product is formed. Next is addition of ammonia and its derivatives. Okay, addition of ammonia and its derivatives. So plus NH3. Ammonia is NH3. So what is added here? So your nitrogen attacks the carbonyl compound. Okay, and what is happening? So you are going to get here C. Okay, then so this will be OH. This will be NH and H. So this will H will attack here NH. Okay, and this H will go and attack here. So I am going to get what? I am going to get a imine system. Okay, I am going to get a imine system. Okay, so if I have got a imine system. Is it clear? Is it clear? Okay, so addition of ammonia and its derivative. So very important. Mark this as important. So addition of ammonia and its derivative. Okay, so aldehydes and ketones, they react with ammonia. Okay, and its derivatives. So we are using a very weak acidic medium. Okay, and what it forms? It forms a compound which is containing the carbon nitrogen double bond. Okay, which is called as the imine. Okay, which is called as the imine. Is it clear? Okay. So we are going to form this one more nucleophilic addition reaction. Yes. Okay. So these are the different systems. Okay. So here we can react it with the ammonia, first one reaction. So your aldehyde or ketone with ammonia. Okay. You are going to get a imine. So if you react aldehyde or ketone with primary amine, I'm going to get a substituted imine that is called as a Skips base. Okay, we can use a hydroxylamine. If I use a hydroxylamine, I'm going to get a oxime. If I use a hydrazine, I'm going to get hydrazone. If I use a phenylhydrazine, I'm going to get phenylhydrazine. So there are different products obtained by using different amines. Okay, with respect to ammonia, with respect to primary amine, hydroxylamine, hydrazine, and phenylhydrazine. So you need to know all these. Okay. So yes, so here we are reacting this with what? This is our 2,4-dinitro phenylhydrazine. Okay, that is 2,4-DMP, this reagent. So here we have got phenylhydrazine. So this is a phenylhydrazine. And here what we have got is so NH2, okay, NH2NH, and your C double bond O this. So this is semi-carbazide. Okay, this is a semi-carbazide formation. So this is a phenyl hydrogen. This is a semi-carbazide. So 2,4-DMP derivatives, they are yellow, they are orange or red. Okay, useful for the characterization of aldehydes and ketones. So these are different color, 2,4-DMP, yellow, orange, and red color. So these are the useful for your characterization of aldehydes and ketones. Okay. Yes. So these were the things, okay, which we had to discuss today. So what all things we have discussed? So just we will recapitulate the things what all we have discussed. Okay, so this part reduction and the remaining part we shall be discussing in the next class. Okay, so let me discuss the things which we have uh, done today. So we have started with the methods of preparation of aldehydes, okay, only aldehydes specifically. So from acyl chlorides, we can prepare, that is the Rosenmund reduction. Then we have seen from nitriles and esters, which is called as the Stiffen reaction. Then, so by using diisopropyl aluminum hydride also, we can convert the nitriles, okay, to aldehydes. Okay, then from hydrocarbons, okay, you can hydrocarbons also you can do, okay, that is by converting the aromatic aldehydes, okay, which can be prepared. You can convert the aromatic hydrocarbons into the aromatic aldehydes, okay, and using the chromyl chloride test, and which is known as the ITART reaction, very important name reaction, ITART reaction. Then we have seen the use of chromic acid, how we can use chromic acid, okay, chromic acid. So we can use this on toluene or substituted toluene, okay. It is converted into benzylidene diacetate, okay, and so this on further hydrolysis will give you corresponding benzaldehyde, okay. So this also we have seen. Then by side chain chlorination followed by hydrolysis. So this is one of the important reaction for commercial scale preparation of benzaldehyde. Then we have used Gatterman-Koch reaction. Okay, very, very important 2 marks question. Then also we have seen the preparation of ketones. So first was by from acyl chlorides, then from nitriles, then from benzene or substituted benzene, which is also called as a Friedel-Crafts acylation reactions. Okay, then we have seen the physical properties. Okay, that is the physical state, boiling point, solubility, odor. Okay, then we have seen the chemical reaction, how the aldehydes and ketones undergo nucleophilic addition reaction. Okay, so mechanism we have seen, then reactivity we have seen. Okay, then we have seen some of the important examples of nucleophilic addition reaction, that is addition of your hydrogen cyanide. Then we have seen addition of sodium hydrogen of sulfide, then addition of alcohols, okay. Then we have seen the addition of ethylene glycol, okay, and addition of ammonia and its derivatives. So these things we have discussed. So the remaining part, that is reduction onwards, we'll be discussing in the next class, okay. Yes, so I shall end this session here. I hope you have understood today's session. Yes, okay. So I'll end this session here. We will meet in the next class. Thank you.